The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people were evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spend a lot of time making sure the accurate information gets out.
This is live. There's still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, the group would just jump in and help out. So it was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
Aloha everyone, I am geologist Philip Ong, here with Mr. Dane DuPont of HawaiiTracker.com, bringing you guys another Kīlauea volcano update. Today, Thursday, December 9th, 2021. In the last week, we've had a 3-day pause. It's been the longest pause of the eruption so far, so we'll talk about that a little bit, and some of the signals that we can see, and some of the time lapses. That's what you guys are seeing here is a loop of what was mostly in our minds as Hawaii Island residents over the past week is the weather. Inclement weather, and then somewhat coincident with that, the pause in eruption and coming back. So we'll talk about all of that. We're going to discuss our live viewer questions along the way, as usual. So pass your questions to Dane in the chat, and he'll answer what he can and collect others for us to discuss as well. And also let him know if we have any issues with our audio or our video, as that does seem to happen with live broadcasts here. So anything else you want to throw in here at the top, Dane? About the last week and the weather, and
yeah, it definitely was a struggle. I mean, I was without power for about 24 hours. You were without internet for a couple days there, so it's good to be back online and everything.
That's right, yeah, volcanic pause, and I had an internet pause, unfortunately, there, but we're back with you guys. Fortunately, did not have to delay today, but so we'll be able to recap everything for you guys today, and mostly that's the story there. Within the last week, last week we talked about the emergence of the 3 new outlets that had occurred over the previous 2.5 weeks. So there's more places for the lava to come out around the bottom of that cone. And as the lava burst forth after this pause ended here, just a couple of days ago, you see it did the same thing, reactivating the outlets on that west vent here. So that's really it here. The slowdown on lava actually began, let's throw this out at the top, began before the storm came in. So there's no, I mean, it just happened to be that the breaks were at the same time. Volcano slowed down first, then the weather came in, and you can see here the west vent cone still active within its inner pit here and its main entry point, but also along its southern entry there and its northern entry that came out, loops around over here and overflows off in this direction as well. That was just the first 24 hours that I captured on the webcam from the USGS. But we have been, as usual, collecting images. Mahalo Dane and mahalo to Bob Martin for continuing to do that and compiling the time lapses here. So to start off here, we'll show you guys just a clip of this most recent pause, right? Which the USGS is in the reports saying is a 4th such pause in eruption. Now, clearly this is the longest one. You can see the lava lurches to a stop there and stays stopped for a while, and then resumes here with that burst. Here it is on loop. Dane, I think you're still unmuted. There it is, that slow lurch of the lava coming through. You can see a bunch of this steam and a quick rain passing through. That's the big picture of what's going on here. Yeah? And as the lava bursts back in, it does burst not only from this southern vent and central vent and northern vent, but it later on seems to pop up in a new outlet up here at this northern part of the image here. So if I zoom it in up here at the top, you see that towards the end of the sequence, we burst open what seems to be a temporary new outlet. It's kind of like an ooze up flow along the perimeter, but it just looked a little different, maybe because of the difference in elevation that was present there. There it is right there. A little bit of flashing here at the very end. So let's step out and let's rewind to the previous such little pause, which by my estimation here, play it, was the last week of November. So about 2 weeks ago or so. This is the 24th and 25th. Not nearly as long, but you can see, especially in this nighttime images, how that fast circulation slows down and you have only a few channels that are sluggish and quite a few areas of not moving goo in there, right? So that perhaps was the time before that, visible from the S1 camera there. And here's one that same event as it appeared from the F1 camera, in case that's a little more easy to see. See here, 24th and 25th. See that when it comes back, even at that point, it reactivates the southern branch once again, and also as well the northern. So interesting to see how there's a relation there, right? We've seen hosts of lava out of the center and the other outlets as well, not following a slowdown, but every slowdown does seem to come back with activation of all those new exit points for the lava from underneath this flooded crust here. So it's been since October 3rd, right? So it's been October, November, 2 months, right, since the vent has been drowned underneath the lava. So we're perhaps seeing some surface adjustments of the exit points there, right? We're probably imagine the long-term stop and start effect of the eruption is more to do with the deeper process within the magma chamber itself, right? Not the deep chamber, but the shallowest chamber still below the ground underneath this lava. It's crusted over. So that's that. Perhaps that previous clip, or previous pause, maybe the third one. Not quite sure. I did go back and find another one here on the F1 camera. It goes back to the 7th of November. So about a month ago is when this started. You can see that first pause that came in. And this is interesting because that was right before we had the big bursts from the new outlets in the south and the north. So when we describe that, you really can see that slow down and then reactivation with that flooding of the events. Maybe you can if I don't scroll it up enough so it's not on the screen. There you go. Play through. There's the burst outs at the end. Now it's going to loop to the beginning, and there's the slowdown with a crusting over, then the lava comes back, resumes its former area. And a few days later, after that slowdown, we have first spillovers but then the bursts of the north vent and the south vent, outlets of the vent, right? It's all still the same west vent. That's back to the 8th and the 9th. So here's a plot of the tilt over the last month on the summit of the volcano. This is a ground inclination, right? So it's responding to the pressure changes in that magma chamber underground, as well as some other stuff that's a little bit shallower, perhaps. And our scale here is getting to be on the edge of significant, right? We're about 9 microradians top to bottom. So these signals are all real signals of some process occurring, and it could be smaller surface stuff, which might be these smaller wiggles in here. And we also have these bigger. That was a spike when those outlets burst out. You might also have this larger signal right here, which was the beginning of our rusting over most recently for the so that began on the evening of the 3rd, so right in here, and came back in on the 7th, so somewhere right in there. It actually went down, started reinflating, and then there was a lag before we saw the lava reemerge at the surface, somewhere right around the peak right in here. And that since then it's gone back down and come back up and gone back down and come back up. I mean, really the story here, the pattern, now that I've got to scale, zoom it in, really the pattern here is this of fluctuation, right? Not just these smaller fluctuations that might be closer to the surface process, but also these larger fluctuations might be slightly deeper, in the range of 1, 2, 3 microradians or so, 3 microradians or so, top to bottom there. So we've had deflation inflation events. This doesn't exactly look like that. It's got a similar pattern, right? It is kind of going down and then shallowing out and then coming back up. And it does have that pattern a little bit, but it looks like there's something else superimposed on it. Maybe this shorter term signal you see back in here superimposed on it. So it's got some funny little wiggles that make it not quite the same, right? So certainly this looks like a deflation inflation signal and deflation inflation signal. So that's what we're going to be seeing more of those. And as usual, these longer ones can cause the pressing over the surface and the changing of the outlets to go along with that. That's the tilt. If we look at the lava levels, we've just finally had that false gas reading scroll off the edge here, so we have some resolution finally in our plot. And this is the last week. Let's see if I can get this there on the screen here. This is the last week here, so we're looking at half-meter intervals here, starting off at 292 and maybe a quarter or so, and ending up at 294 and a quarter or so. I'm up about 2 meters in the past week, which is about the same as we've been seeing the long-term average, right? But we did have a report from the USGS that in this big gap that's happening right in here, which is largely because of the storm and transmission issues here, did report that for several days the lava level had seemed like it had plateaued. And so maybe we saw some variations. Who knows exactly what's going on there, right? But it seemed like it might have been a little bit flatter and then has come up a little bit steeper here afterwards, right? So somewhat corresponding to that deflation inflation event that we also saw. But there's another variable, another component to this lava depth plot here, and that's with the whole configuration of the crater, right? We had previously been seeing lots of overflows in this back area, the west vent over here, and so we'll get to that and how that can affect the if you lose more lava out in that direction there, then you can spread it out thinner, and you expect the rate of increase to slow down a little bit, right? That's the kind of the longer term pattern. But what we're actually seeing upon the resumption of the flow here is that we've resumed that longer term pattern despite that extra space over there, and that's because, as you can see here, as the lava has resumed, the flows on this northern downdrop block have not resumed, and so we've seemed to have cut off, at least temporarily, that little supply there. And what you see here is a burst. So I've kind of screwed over. There's our main return of lava to the west vent here, and you can see it's flooding out the north over here. I'm sorry, the south over here, and the west. Some of these cracks that we haven't seen open up before. Up here in the north, where it seems like this tube that flows around into the pond. Seems like it breaks open in this area quite a bit as well, so we're seeing that. And overflowing off in that direction. But also around over here, this is that curious new spot, right, where you actually see, it looks similar to those ooze-up flows in the sense of where it originates, right along the edge. But the size of this channel, which to me indicates the flux, right? The amount of lava coming out at once was pretty high. The actual rate of lava coming out was pretty high to actually channel of that size. So I wonder if this area of the perimeter was a little bit lower, so it had extra space to come up, right? But if you actually look at this image, you can see this whole area is starting to lift up, right? So it almost seems like the surge of lava that's come in after the pause has lifted up this western area more so than the eastern area, right? Now that we don't see the lava coming out of the east anymore, and that's now propagating its way around. So it fills and floods this whole area, works its way underneath the crust, it pops open over here in the north. This is somewhat near the old north vent, right? But this is actually, the old north vent would have been way further inbound of the crater edge, because it occurred when the crater was much narrower back in December 2020. And as it is, it's coming out along the edge and then putting out this big flow that's moving to the north. So maybe it's bulging upwards on this side, allowing it to put out that much lava out in that direction, right? And this is a capture of the 24 hours from the 7th. So if we advance to the, this is what I didn't. Let me find what I need. I want to show for you guys the current F1 camera. Current view here, you see that spot is no longer active, but there are ooze-ups occurring in other areas closer to that down drop block and here along that southeastern side as well. So take it to the last 24-hour loop here. Gives me some zoom. And here you can see the remains of that ponded area. Seems like it's overturning lava, so maybe it's still feeding in there, but it may be feeding mostly underneath the crust and feeding around. This whole crusted over lava flow was advancing over in this direction there. But to keep it going around, you can see there's a little bit of ooze up coming up right along the edge of that down drop block. And you see a little bit of brightness here on the tip of that down drop block flow. So it did reach a little bit through there and put out more lava, although we haven't seen the big flood of lava come out there yet. So the path has been reconnected within the last day or so. Well, that's the F1. That's the signals of how the lava seems to be moving through the crater once again. And we do have a new map to consider here. So this was released just today, December 9th. And we have, as usual, our statistics down over here. So if I come in a little bit closer, the biggest difference here is this extent of overflows that you see on this down drop block, largely because the last map was put out about 3 weeks ago or so. So quite a bit of a difference as far as that area. And of course, you're growing a little bit in the perimeter. There was a spot that maybe you can see right in here where the lava is gaining a little bit of area as well, or it's starting to come up on a slope of this block here as well. But not nearly as much there, much more largely. So over here, the active area of the lake in red has not changed really. And really the statistics is what I wanted to come in and look at a little bit closer. So to start off with, the full lava extent, including that overflow block, is 173 acres or 70 hectares there. Now for comparison, I went back and did not, hold on, I gotta pull up an image here that is the map from November 11th. So back on November 11th, you can see that we had labeled on a map just small overflows, but really no large extent on that block yet. So for point of comparison, this is what we're missing right there. And at that point in time, the full extent of lava was 155 acres, 63 hectares. So you can see we've grown 7 hectares or 18 acres. And I would imagine that's largely the size of this thing down here on this down drop block over there. Right, did I do that right, Dane? Did I do any math errors in there? 155.
I'm gonna go with yes. I was typing for something else.
Yeah, wait, I don't think it's 18. Yeah. All right, so that's 9.7 billion gallons so far. Right, compared to 3 weeks ago, that's or actually it's about a month ago. Right, through November 10th is that map, and this one is through December 7th. Right, so let's call it about a month, and 2 billion gallons difference in that month. Right, now, of course, there's some error baked in here because of that error we know from how they collect this data. But that's still impressive if you're looking at the rates of how things are changing here. The active area of 17 acres has not changed. That's still the same. As far as our surface, we are now up at 809 meters or 2,654 feet above sea level. Still quite a bit down within that pit, right? If you let me scroll back over here and zoom it out a little bit, perhaps, you can see that we're still, our closest pit that we can fill in is about that size right in there. And then there's another one that's right through here, and then there's another pit up through here. So there's lots of areas, lots of space for this to fill up without having to go anywhere, and it's still no threat to anyone. It's still just of curiosity. You got something, Dane?
Yeah, Richard's asking about the clarification on the depth of the what it means by the lava thickness on that chart.
The lava thickness is the elevation difference between before September 29th and today, basically. Right, and I had that. Maybe might be able to find that other picture from last week, but I don't have it right on hand. Second, pull up that cross section to show you guys. Assuming I can navigate the new USGS website here.
Yeah, USGS, for those that don't know, have been making a bunch of web changes to their UI and the navigation as well. So it takes some getting used to say the least.
Yeah, and this is all happening as we speak. So some of the links work, and then they are updated, and then something else changes while you're not looking here. So what I'm looking for here is the Volcano Watch archive. See, the new homepage is showing today's Volcano Watch, which we'll talk about, but not showing the one from last week. So maybe what we'll do is we'll go to hawaiitracker.com. It's on there, yeah, Dane. Scroll back and find that Volcano Watch. Somewhere in here. Must have gone back too far. Is it just last week's one? Right. Thrilling, I am sure, to find this thing. But no, not finding it here right now. I'll see if I can find that later on one of the other breaks here. So, but yeah, it's still quite a ways down. I can give me some white here. I can sketch it for you guys, right? The old crater collapsed down, something like that. Our original eruption last year was that far, and we've come up about that far, right? So that's our about how our profile looks, or something like that, right? That distance there, a little rectangle on top, that's that thickness. To answer you, was it Richard? So mahalo for the question there. So, and then the total depth, if you were to count all the way down to here, we're similar to range of close to between 950 and 1,000 feet total from the last eruption and this one together. Okay, so it was something looked at. So we'll look at the comparisons here. That new, let's pull it back here. This newest volume of 36.7 million cubic meters. This is getting up there now, right? Our last eruption ended at 41, so we're getting pretty close. The rates are pretty low, so we're not gaining that fast. But depending how long this goes, we may yet surpass it. And to illustrate that here, I've drawn in red. Our 36.7 comes out 37, but at the same point, that is, we are now 69 days into the eruption. At that same point, or I want to say the 7th might have been 69 days, so we're a couple of days since then, 71 days into the eruption. At that same point in time, we had 36 million cubic meters. So we're slightly above now. We've caught up, and we've slightly exceeded up to this point in time, this many days into eruption, the total rate, right? So you can see here, blue was the December 2020 to May 2021. Started off faster, then slowed down faster, and was going slower by this point in time. Whereas we, in September 2021, started off pretty fast still, but not quite as fast as in December 2020. Stayed pretty fast for a ways, and we really haven't slowed down that much yet. We haven't come to any real flatness, right? It's really, you can see that if I connect that point to here, it's just pretty close to curving a little bit, right? But it's pretty close to a direct line there, not a whole lot of deviation. So this is the question here. Will we keep going upwards? Right? We'll keep going upwards and exceed this 41? Or will we flatten out and who knows? That's the story that is yet to come. Okay, and this is interesting because this is happening despite the fact that our most recent interval gives us an eruption rate of 2.6 cubic meters per second down here. Right, and so you can see that the actual intervals are a little bit arbitrary by when they put out the maps. So the actual number is not as important as a trend of them, right? So you see the last eruption in blue here. We came down, bounced back up, came back down. It's fluctuation is normal, and then settled down at this low value of more or less, we'll call it 1 to 2 cubic meters per second. Here in the red, we know that we started off high, not exactly how high, so I've left it off, but we've come down from initial rate of early rate of 28 down to 4, bump back up to 6 to 7 to 8, came back down, bump back up slightly, and now we're back down slightly again. So we're catching up without having any crazy eruption rates. Eruption rates are still waning. You're still, but there's, you can see that, if you were to compare 2.6 to 0.6 as a factor of 5, of course, just 1 point, but you can see how that maybe a factor of 2 to that, or a factor of 1.5, depending on how it continues and how it tails off there. So that's fascinating. And then one last thing, I gotta pull out somewhere else here. I had my computer decided I wanted to rearrange my. This is the active area in acres. So the last eruption was in a smaller crater, so it filled the whole crater up by this point right here and came back down and was at 17 acres right around this point in time to the eruption. And in red, we had a larger crater initially, so we came up higher, came down faster, and we've stabilized at the 17 acre for a while, right? And actually, we've now come to, once again, pretty closely match the last eruption at this slightly over 2-month mark into the eruption. Okay, so that's the trend of the data there, and so we can look at USGS updates for a little bit more information. And this is, of course, our source for all of this is all USGS plots and images and webcams, and we may be compiling them and pulling out the clips and all that, but it's all sourced from USGS. So back on Saturday, December 4th, they reported that the rate of eruption had increased sharply, but nonetheless, all the lava was still in the park. They note here that on the afternoon of the 3rd, between 4 and 6 p.m., the rate of effusion decreased sharply, potentially marking a pause in the current eruption. A small portion of the vent cone collapsed at about 5 p.m., though there appeared to be no effect on eruption directly due to the collapse. The western end of the lake has shown little change in maximum elevation over the past several days, with the laser rangefinder showing an elevation of approximately 809 meters above sea level yesterday. That's what I was referring to before, that possible stagnation and the lava spreading out onto that eastern, or that northern downdrop block, perhaps, right? Or perhaps combined with some lowering of the effusion rate, because that was visibly noted later on in that sequence. Okay, so that is the highlight for the 4th there. I'm going to scroll up here, and I've got several of the days lined up here. Won't read everything, of course, but I wanted to just pull out a couple of interesting things here. I think we'll skip over the 5th. We'll go here to the 6th. And on the 6th, we see here that they note, this is the 4th and largest such slowdown or pause since eruption began on September 29th, and none of the prior events lasted more than 24 hours before resumption of normal eruptive activity. They note the reinflations recovered the tilt, but tremor levels remain fairly low. So they are noting that, a little bit further up, volcanic tremor measurements have been erratic, but are substantially lower than values prior to the pause. So not only are they seeing the decrease in lava, it's picking up on a tremor as well, which is interesting because that's, let's say you do have a whiteout and you're wondering what's happening behind a whiteout, you can look at the tremor as a proxy for if the lava is moving through the pathways and causing that harmonic vibration that causes the harmonic tremor. So when it stops and we know the lava is just not moving through there, something is going on, like that deflation inflation event, or something that's blocking lava. Maybe lava is draining out temporarily before it bursts back up and through. Okay, so that's they do note that the weather has had a drastic effect, not only on tremor measurements. Of course, there's been no gas measurements made, only the continuous measurements here. And so this is noted. We've talked about this before as well, how we know that USGS was running continuous measurements of SO2 in the past, and we didn't know the current status. But here they note, continuous measurements indicate SO2 emission rates have decreased with a change in eruption rate. So they all are noting that they do have those instruments, and they are monitoring them, and they are following that same pattern, right? But don't have access to them. Okay, that's the from the 6th. On the 7th, there's one point that's interesting, and this is not so much after the resumption here, although we can say here that the lava re-entered the vent and resumed erupting between 5:30 and 6:30 p.m., ending the pause that began on the afternoon of Friday, December 3rd. Both ground inflation and tremor peaked around 9 p.m. on the night of the 6th, and tilt meters that showed deflation activity and the earthquakes is still low. Right, so lava reemerged from the vent at 6 p.m. last night being the evening of December 6th, and had covered the prior extent of active lava lake by about 3 a.m. on the morning of the 7th. The eastern edge of the lake that advanced into the lowest of the exposed downdrop caldera block floor blocks remains stagnant. So that's what we're just covering right there. 4th and largest decrease, none lasted 24 hours. And similar as what we've covered here before, so not to reread it. But what I wanted to focus in on that's different in this day's update is here in the East Rift Zone observations, where it does say, no unusual activity has been noted in the Kīlauea East Rift Zone, and there were no indications lava migrated in that direction during the pause. So thank you, USGS, for putting in something explicit about the Lower East Rift here to direct our Lower East Rift Zone residents and viewers. Right there, that's a key note that we don't see that often, but it's in case you were wondering, they don't often say this is not happening, but they did throw one in here, acknowledging the concern of the residents. So everything's essentially back to normal at the summit, and still no change as far as progression of lava outside of the summit. So that's what I wanted to highlight there. Move on from the text for now and show you guys this GPS link. This is across the East Rift Zone at Pu'o'o, going back to last year. And you can see that the distance is still continuing to contract. And that's what the slope going down. If it was going up, like it was over here, that means it's spreading, which might mean magma is filling underground, which is normal also without having to erupt and anything. But that's just one of the states of its being. But we're not even to that. We're just showing it actually contracting as if the magma has been moving or cooling or leaving that area, or essentially not causing the ground to swell. I mean, it could just be that it's interesting because you see the south flank there moves away and could cause some adjustments at the drift zone above it as well. So it could be something like that. Okay. I see a question here about the cone. We haven't had a measurement on the cone recently. We do know the lava has been filling the lake and drowning that cone at the bottom. So we really don't know. I would guess maybe 2/3 to half its former height. Right, its former height was 20-25 meters, 80-85 feet. So maybe 50-60 feet would be my estimate. What do you have, Dane?
I got a few different things, but I'll let you finish on that one first.
Yeah, that's as far as the height of the cone. Yeah, that's what I can say.
Yeah. And it's so hard to track the height of it because everything's kind of moving in there and adjusting, and what's your point of reference. So I think that's about right. At the end of the day, we do have a couple things I've sent your way that were released in the past little while or in the past day. We can bring some of those up and talk about them when we get through this first part.
Okay, sounds good. Yeah, so let's see if there's anything else that's relevant quite yet, and maybe I'll take the question from Richard here that says, can the recent pause be due to a lot of the gas being released and affecting the plumbing system somehow? Mahalo for the question, Richard. Certainly, it could be that variation, right? We've talked about how the gas pistoning / deflation inflation cycle is thought to be something to do with that denser magma that's gas poor, essentially being able to sink back in, and as it does so, it's blocking the pathway. And then once it clears enough, then all the fresh gassy stuff that was blocked below that comes rushing in, and then it reoccupies, and it can re-release that. And so it does have to do with the gas movement. It may not be exactly the gas displacing the lava and coming out instead of the lava. We're seeing actually the gas and lava coming out at a 1-to-1 ratio, right? So the amount of lava coming out goes down, and the continuous monitors are showing the gas going down at the same time. So that's why it's thought to be the actual gas poor magma moving down and blocking it, and then the burst that comes afterwards of that built up, however long the pause or build up was. So one other question about that back part of the northern down-drop block from Marin. Mahalo, Marin. Did the breakouts in the back reduce the difference in level between the active part and the back at all? I would imagine that's really been doing a lot of the work prior to the pause. We have not had a report of the depth to the eastern part of the block for a while, so it's hard to compare that to that western area. Right? If the western area was not going up, and we're seeing flows on the down-drop block at a similar time, that's a reasonable proposition.
David asks, do you think the USGS will install another camera since it's overflowing, slightly getting out of frame?
I believe they will, probably. There's a little clue within today's Volcano Watch that they have volcano-proof cameras ready to deploy, so perhaps they're going to deploy one somewhere. Maybe that's what that means. I did mean to show...
Speaking about the Volcano Watch, and we were talking about the USGS making site changes, right now it's given a 404 error if you try and pull the Volcano Watch, so we'll get that posted when we can get it.
Yeah, I think I might have it. Well, we'll see if my browser kept it loaded or not, but somewhere on here I also had the B1 camera, and I might have lost that as well.
We also got to fix a couple cameras that are kind of stuck after the storm.
Yeah. But yeah, so here, let me throw this on here. All right, so the B1 camera, the reason is we're talking about this is that this is the camera that was catching his overflows in the down-drop block over here in its right part. but now has been frozen since the 7th, right? So we can't really see anymore, and that would be a great place to deploy a camera. Might be somewhere over this way that looks back across this in the foreground and back to this in the background, right? But interestingly, this froze during that resumption of lava right through there, and it's interesting to note that we still have this pinprick of light. This is all washed out everywhere, right? But there's one bright spot right here, and what's in the foreground of this view, which is that area near that little islet. So it seems like when you see that reactivate, a pretty good indication that the lava is moving underneath the crust in that direction once again. And so that was a clue that we were going to see the resumption of flows, and we did see a little bit of red popping up on the edge of that down drop. Right, so I wanted to just finish off the East Rift Zone here and some of these other signals, and no signals on the GPS on Pu'u. You do see a little bit of this variation, but nothing significant. Earthquakes, also none. Right, there is a little bit more activity down in Pahala, but just compared to what it was previously, it's they're natural variations, and it's elevated in the long term for sure, but no other answers and no new information on that. So focusing more on Kīlauea Summit and East Rift, there's really nothing there. Right? You still see our typical south flank activity all through there. They're all time, no matter what we do, no matter what day it is or what's going on. So here's a plot for earthquakes over the last year. Earthquakes per week. Right? So down here in the last few months, we've been pretty consistently low, lower than non-eruptive times, and lower than in times. So there has been gas coming out still. We talked about the continuous reports, right? This is the most recent plot from the USGS, and you can see that the last data point was before our last broadcast. There's really nothing new here on the right side. We'll have to wait for some new data there. We just have that USGS text update to go with. But we do have our VOG mapping project here, a VOG forecast for the next few days. The trade winds are back, and VOG is blowing to the southwest, to the Pahala, Ocean View areas, as it most frequently does. Whereas during this last week of storm, we had a lot of the wind coming southwest to northeast or south to north. That's what knocks over a lot of our trees and pushes that VOG all around the island and elsewhere across as well. Of course, with all that rain, you probably couldn't. If you had rain in that part of the island where you were with your storm, then you may not have smelled that VOG. All right, so that's all the data. We can keep addressing some questions here, but maybe we want to say some thank yous first. What do you think, Dane?
Yeah, and go ahead and pull up some of the stuff that I sent your way.
Okay.
Also gonna send one last little thing for you, but yeah, we will get into the thank yous and we'll get into the question and answer segment. We do want to thank the viewers. Really, they're the ones that make this possible. Like, share, subscribe, all that really helps get the algorithm going. We don't have the funding to do publicity and all that kind of stuff, so we rely on word of mouth, and just sharing it with friends really helps it out. It helps the channel grow and all that kind of stuff. So take the time if you could. We do take monetary donations on hawaiitracker.com/support if you are so inclined. hawaiitracker.com is where we post all of our latest content on the volcanoes. So if you want the latest in chronological order, come check out hawaiitracker.com. We do want to thank a couple of our sponsors, first being Kīlauea's Bar and Grill on the heart of Pahoa, and also their new location out in Orchid Land. They have 2 unique menus, so you can get a little bit different experience at both establishments. Indoor, outdoor dining, takeout options. They do some unique twists on some local dishes, as well as some traditional dishes with some local twists. So if you're visiting or come on, definitely go check out Kīlauea's Bar and Grill. We also like to thank Kalani Tours. Kalani Tours do a variety of different kind of tours, including Konakavi Farm and waterfall tours, but also they do a few different lava tours, and they do them in smaller groups so you can get your questions answered and get a little bit more personalized experience. So we thank Kalani Tours and Kīlauea's Bar and Grill. We also thank the Hawaii Community Foundation through the Puna Strong Grant, and as well as the County of Hawaii.
Mahalo, everybody.
All right. So I don't know which one you want to go through first, but the there's some steam tornado, one of those steam vortexes that was captured by Robert, and he provided some photos. Interesting thing was he messaged the USGS about that to get their take on it, and they sent that second photo that I show there that I sent you, and the timestamp on that one is 9/12, which is interesting because the closest one I have to that mark is 9/13. So the internal servers at USGS are updating at least every minute on these cameras.
Oh yeah.
Though the public facing is only getting 10 to 15 minute intervals. But that the little vortex from two different angles is caught on the cameras, which is kind of cool.
There it is. Draw on it here, right? The little vortex right there. And here is the other image.
So yeah, thank you, Robert, for sharing that. And he did post that on Y Tracker as well. They do have a comment I want to get your take on. They said, thanks for sharing. I don't think something like this has been observed in Halemaumau before. I looked at the archive for other Kīlauea Summit region cameras and caught a little bit different angle showing the Steam Devil and the KW camera. I remember those Steam Devils or those vortexes were pretty common in 2018 down the Lower East Rift Zone. But I can't remember any inside the crater, at least specifically. You'd think there would be one, right? At least an image of it. What are your thoughts?
As far as an image that's been captured, that's tricky. I'm sure that there are some around somewhere, right? Because a lot has to do with having a lot of steam around and having hot areas in the ground.
Just the right weather conditions too. Yeah.
So yeah, I'm not sure if we've had it on the camera necessarily, like webcams as such. I believe some of the local photographers have these kind of things caught. I have a hard time thinking of who might have that, right? I want to say that Sean King might have had something. When I used to run into him photographing at the summit. It's
you think Janice or somebody would have one?
Yeah. I'm not sure how recently we've had it observed. Yeah. And
I remember in 2018, those things were like you could see multiple a day. It was hard to get the camera out fast enough, type of thing, before they dissipated.
Yeah, absolutely, yeah. But yeah, thinking more within a crater.
Right.
In 2018, I'm not sure. I mean, when we had the lava lake in Halemaumau, we were fairly high up, and it was overflowing onto the crater floor. I think at that time you might have had something like that if you'd had a bunch of rain at the same time. So I would look in that pre-collapse era. There might have been rainy a couple months right before that, I want to say.
Right.
So yeah, maybe in that range, right? But I do want to point out, that we did do a recap of that whole March 1921 eruption, on Jagger's account, and Jagger describes in written form the whirlwinds of steam and gas that are picking up pieces of the crust and hot lava and flinging them out of the crater. Right. So the actual feature itself is not that rare. Maybe it's uncommon because of you don't have lava in the crater all the time. But when there's lava in the crater, it's not that uncommon, and it's been noted many times in the past descriptions of Jaggers, and maybe we're starting to catch them on camera more often now. So that's pretty cool. So mahalo for sharing that. And that's a cool little thread to pull on there.
We have a 790 Miramar Ringgit super chat from Colburn. Says good info for you from you guys. Appreciate it. Appreciate the support. The second one I sent you is a Sentinel-2 time lapse with the thermal image of the crater over the past September 24th to December 8th, so 2 weeks thereabouts. And it just shows some of the activity in the die off and a little bit of the clouds, but figured to show it since it's new and got the images processed.
Yeah, it looks great. Yeah, and these litter frames, you can see more of these ooze ups around this outer perimeter right through here, which I think is pretty cool. Cool, yeah. Of course, this is, as you guys have seen, a lot more of the detail of the time lapse from the ground, right? You're really missing a lot of the detail in there, but you do get the overall sense of it and get some interesting features that you can pull out of that, which is fascinating to me, because even our time lapse animations are missing quite a lot of detail compared to, as what you mentioned, USGS having stuff come in every minute.
Yeah, that archive that'd be nice if they afterwards could put it into Sciencebase somehow. Would be pretty nice. Just my thoughts.
Yeah, well, we know that the public has been clamoring for live cameras from the USGS for a while, right? And so they essentially have the capturing capacity happening, right? But they don't have anything else going on with that, right? So I don't know if there's some technical challenge, a barrier right there that maybe we hope that they can overcome at some point, and more frequent images there.
The last one I sent you is a screen capture, which is just kind of funny. It's nothing against who posted it, but just the ESA released this image, this model, and it looks like a bloated Mauna Loa.
See if I can get it to brag. Yeah.
It's like that. Nice try. Keep tuning it a little bit.
Yeah, it's definitely vertically exaggerated. Yeah. Right.
It's cool they're getting it there, but not quite yet.
It really accentuates that semi-caldera.
It would work for like the new Microsoft Flight Simulator, but other than that, I don't see the use really of something like that.
Right.
Well, we can get more accurate, and with using the DEMs that we have to render models. But okay, yeah, that came out. Figured we'd show it. And they got a little snow cover up there, and we've been getting a lot of snow cover. For those that aren't aware, like blizzard warning conditions up the summit. Guys, we're getting videos of people up there snowboarding, all that kind of stuff. So the snowy summit conditions up on Mauna Loa and Mauna Kea.
Yeah, the clouds from my point of view haven't cleared enough for me to actually see it yet, but yeah, I can't wait.
Right. All right. Well, let's see what else. I did have a question for you if you want to get into this Q&A a little bit.
Okay, yeah.
Hit up the last ones we don't have. So Kevin asks a little bit about Pu'o'o, and he's heard rumors of some puffs or some clouds over it over the past month. Is that true, and does it mean anything?
I believe people when I say they see them, so I would say it's true, but I haven't seen them myself. But that's not surprising, and it's not concerning, because we know the ground is hot in the rift zone. We know there's a bunch of cracks, and we know that when it rains a whole bunch, that allows more steam to come out. That's one part of it. The other part, as you mentioned, is we're starting to change our weather pattern to more of a winter pattern where we have variable winds, and so that doesn't always blow the plumes down, but allows them to kind of build up higher and higher and higher, so they look bigger and more imposing, even though really it's just an effect of the wind pattern, right? And that happens not only over Pu'o'o, but over Halema'uma'u as well. We mentioned last week how someone had even seen the top of Halema'uma'u's steam plume from Hilo, right? Because that's how tall it had gotten overnight in a slack wind conditions. Yeah. So yeah, I mean, what we stick to is the monitoring signals, so GPS, all that, the tilt, all the other stuff, and there's no indication of anything happening in Pool Sur volcanically.
Right. Just living in Leilani around the steam, that the steam means very little in and of itself. Matters mostly about the dew point, what the steam's going to do, what the temperatures. It's atmospheric conditions in a lot of ways that dictate the visualizing of the steam. Right. When the steam's mostly consistent day to day, you can still see some wild fluctuations in just the visual aspect of the whole thing.
And I can throw on here just to bring this up as well. Like, we've talked about this. It's probably been 2-3 weeks now. But the study done post 75 earthquake during a Pu'o'o eruption showed that even with lava coming out of Pu'o'o and the whole Lower East Rift contracting, you still had massive settling of the rift zone area without lava going in there, right? So that's documented to have happened and is happening now also. And as the ground is kind of collapsing and adjusting still, you're going to get other appearances of steam or dead vegetation that can as well.
Right. I have a question I wrote out. Figured it'd be something to discuss a little bit. So we've talked about previously that paper that was published in Nature from the researchers out of Florida, the Parkinson et al. Mm-hmm. And they talked in one of their researches about the 2018 eruption and how rainfall they proposed could act as a modulator for shallow volcanic activity. And then we get this, situation with this reemergence of lava and the storm. The timing would seem to suggest, they might say that supports their argument, right? The researchers in Florida might use that as a case in point. And USGS came out in a message and said they don't see it that way with the 2018 eruption, and they put out a statement, I believe, on this last one and said coincidence, right? So what's your thoughts on this whole thing?
The tilt signal that shows that deflation-inflation cycle, right? I mean, deflation-inflation cycle is sometimes they drag on and sometimes they don't. But to have one come up like 2 days after it starts is like totally normal. And it seems like it's got nothing to do with the rain and that kind of pattern of it, right? Looking at that paper in more detail, and I haven't looked at it very recently, but there's a little bit of time delay as all that rain is going to percolate through the ground to the depth where it can actually affect that area. And it was fairly fast. I want to say within a few days, within a day or 2 days, something like that, if I remember correctly.
I think they were saying it also built up in that paper, like over the previous couple of weeks too, and then it was like the straw that broke the camel's back almost thing too as well on top. Yeah, I'm trying to remember the paper. It's been a while since we read it.
Yeah, and and then there's also the factor of how groundwater can affect fault. I mean, water is a hugely important topic in all geology, right? Water affects the pore pressure in faults, and if the fault has a little slightly more pore pressure in the crack, it can move a little easier, and so maybe things can adjust a little easier because they're not exactly lubricated, kind of. But it's got pore pressure effect as well as the actual presence of water. So it's more like hydraulics in that sense, right?
Yeah, I mean the timing on it is just as soon as that happened, I was like, oh, the arguments about the rain are coming, like the rain-induced eruptions and stuff like that. It's coming back. Here we go.
We figure it is, but mostly it's because it's like something people were going to ask questions about, and so if you're one of those clickbaitists, that's a perfect thing to dangle on your perfect lure to put on your hook, right there, right? So we anticipate that because we've dealt with that long enough now, right? And so I thought the same thing. I was like, okay, that's why at the very beginning I pointed out, okay, look, the lava stopped before the rain even started. And it came back, and man, and who knows? Maybe, well, it could have been a 5-day pause, and it was a 3-day pause instead, and a little bit of rain is what.
Yeah, who knows?
I don't know. I mean,
yeah,
maybe, but it's such a minor effect at that point. I think the bigger pressure and the bigger forces are always coming from below in the magma chamber itself. That's always consistent, right? And, and you can get to a point where the straw that comes back with one little thing on top of the next little thing, and then at that point it could have been a rock fall. It triggered something,
or the lunar calendar, like the cycle that we're in, like all that stuff starts to matter.
Right, or a butterfly flapping its wings in China, as people say, right? So I mean,
right, the butterfly effect at that point. All right, well, let's see. I believe that does do it I think we got most of the questions that I had lined up. Do the storms make more fog, or does the rain affect the lava to create less fog, or like does rainfall impact the fog?
So the emissions of gas from the volcano are largely steam and then SO2 and CO2, and then a bunch of other stuff that come together, right? So the thing is that the SO2 and the SO2 component of the output is what's causing the sulfuric acid and the particulates and all that stuff's coming from the SO2 in particular. So you're not getting more SO2 coming out of the volcano because there's more rain. You do get a bigger cloud, but that cloud is because there's more steam, there's more water vapor component of that output of gas, if that makes sense. So there's more stuff coming out, yes, but there's probably a similar amount of the SO2 is not changing by how much water is available to turn into steam. That's coming out of the magma itself, and that's directly related to how much magma is coming out, which is why we measure that as the proxy for eruption rate. So what's
the one thing I was thinking that might actually have some impact would be particulate matter, right? Getting attached to the water and pulled out of the air. Maybe the larger piece of the particulate matter, maybe a minute impact.
Maybe so, right? But the SO2 starts off more in its pure form. The particulates increase in proportion with time after the plume migrates away from the vent as well. So if it's flying through a wet atmosphere, and the atmosphere is wetter overall, that could, accelerate the process. But as far as how much starting material you have, you still have the same amount of sulfur molecules to start with, and so you can only make so much of that stuff.
It's just the filter might get a little stronger.
Yeah, you might get more filtering on. Yeah, but yes, as far as producing it, yeah. So an interesting discussion there.
Yeah.
For sure.
All right. Well, I think that does it for most of the questions. Let me check on the Facebook one last time.
Yeah, I'm not sure if I can get that Volcano Watch lined up. Right, there is Volcano Watch today. That is the USGS's foray into 3D printing in support of their operations, and so that's pretty cool. We'll have that posted at some point, and you guys can check that out. They talk about how they have different grade printers. One that's got the carbon nanofibers in it for extra strength, right? So a really good strength to weight ratio that they can use on drones, that kind of thing. So goes into some of that detail. So you can look for that. The other thing happening in geology world currently is that the AGU conference is kicking off, hybrid conference both in person in New Orleans and online. See if I can get a screen to show you guys here. So that's going on all next week, and so we do, as usual, see the USGS representing with some research and collaborations and other research being presented at that meeting. So we'll have more of those threads to talk about. Maybe a little bit preliminarily next week, but more so the following weeks, the rest of the year, and on into next year, right? Of course, January next month, Volcano Awareness Month, usually brings a whole slew of talks from USGS scientists as well. They often piggyback their presentation preparation, right?
Right. We also had, I don't think I said it, a $20 super chat from Robert, and we appreciate that, just as you're amazing. Definitely. Thank you. And the AGU thing is awesome because there's often some good research that comes out or gets flushed out further.
So
people have been working on their presentations and their data collection and all that for this one type of expose, or where they just go through all these different researchers projects that they're working on. And some of them are very in depth, some of them are a little more tuned for the layman, but definitely good stuff.
Yeah, this is a huge conference. Of course, I'm sure lots of our viewers are familiar, right? It's not just geology; it's all kinds of stuff. So we really hone in on one little aspect of it because that's really our ultimate goal, is to inform our local community about how the volcano works, so we can be better prepared, be more resilient, and educated, so that when the next eruption affects us in some more impactful way, threatening perhaps, then we're prepared to deal with it and to help our neighbors and all of that, as well as all the people who are around from here. So that's our ultimate goal, is community building with all this, right? So we're really going to hone in on volcanoes and how they affect our local communities and how they work that aspect of it. More so than, for example, if someone develops a new mapping technique, that might be cool, but it might not be something that's really that relevant to our viewers, right? as opposed to here's the results of what happened in 2018 is still mostly what we're seeing follow up on the 2018. So more on that coming up in the next few weeks.
All right.
Got anything else, Dane?
I think that does it for now. Just waiting for the USGS site to return the volcano watch. Whenever that does happen, we'll try and get that posted for you guys.
Let's see if I possibly have it. History probably won't.
Oh, if it's on, I mean, if it has to refresh at all, it's gonna 404.
Yeah, there it is. Everything is.
You would have to basically get lucky with it be up, screen capture it, then we run optical character recognition to put it back into text. That would be the only way.
Yeah, maybe that's why my browser kept disappearing windows, is because SGS was pulling them out, pulling the rug out from under.
Pretty much,
as I was trying to broadcast. So yeah, look for Volcano Watch as well. All right, you guys, mahalo for joining us once again. We'll be back with you guys once again next week. We don't expect anything really alarming to happen. If it does, we'll hop in sooner, but otherwise we'll be back in another week on Thursday. Any last words, Dane?
Nope. Stay safe out there, and I'm glad that we're back online and everything worked out. We almost were having to delay the live stream today just because of the lingering issues of the stream. So glad this all happened. Yeah,
managed to work out for the most part. Mahalo, everybody. Thanks to you guys who contributed with discussions, questions. The guys who please like, share, and subscribe. That really helps the most of everything, right? And if you can go a little extra, we do appreciate that much. Until next week, aloha, everybody. For Dean DuPont, I'm Philip Ong. Aloha.